Hello there, everybody. This is the second part of the lecture 4 on special trig limits. In the first part of the video, and I don't have all the notes here, but we established two important things. We established the limit of sine of a over x, the limit as x goes to 0 of sine a over x over bx was a over b. And if you can also flip that upside down and get the limit as x goes to 0 of ax over sine bx is a over b, right? So anytime you have an x and a sine and a fraction opposite one another, then your limit is just the ratio of the coefficients of the x's. And then we also did the work, and I don't have it here, but we did the work to show that if you have 1 minus cosine x over x, the limit as x goes to 0 is actually 0. And that doesn't matter whether there are coefficients to x or not. So even if I put the ax and the bx in there, here and here, it still comes out to be 0, no matter what those numbers are, okay? And we're going to be able to use those. So we worked hard in the first lecture video to establish those, and now we just get to use those. So these should go relatively quick, okay? So for our next two examples, that means whenever I see sine x over x and the limit as x goes to 0, that's just the coefficient to whatever the x's are. So the numbers in front of the x's, in this case, is just 1s. So my answer is 1. And when I see x goes to 0 for 1 minus cosine x over x, that's always 0, okay, no matter what's in front of the x's. So then we want to jump down here and look at some more examples, okay? So number 1 here, again, we're looking at the limit as x goes to 0 of sine 3x over 5x. So I've got my sine x and my x opposite one another in the fraction. So I just want the ratio of the numbers in front of the x's, and that's my answer. And I don't have to show any more work than that. I'm just using the fact that I know that this limit as x goes to 0 of sine ax over bx is a over b. Now in number 2, I want to use that same idea, but in this case I have something cubed. You've got two options here. Number 1, you could say, okay, well this is the same as the limit as x goes to 0, because I want to use good notation. And it's the same as if I had sine x over x and put the 3 on the outside, because both parts are cubed. And then the limit of what's in here is 1, right? Because that's our special limit, sine x over x. And then you would cube that to get just 1. Okay, and that would be my answer. So that's one approach. Another approach, which I kind of like better because it's a little more consistent with what you're going to see in the next few, is to say, okay, again, I'm using my good notation. So limit as x goes to 0. And I'm just going to spread this fraction out and give everything some space. So I'm going to write it as 3 separate fractions multiplied together. And so I'm going to write out the sine x cubed, means I have sine x multiplied 3 times. So I'm going to put each sine x in its own fraction. That way it has space to breathe, right? Give it its 6 feet of space. Now, on the bottom, I have x cubed, which is just x times x times x, and I'm going to put 1x in the bottom of each fraction. That way, each x is paired with a sign, but in the bottom, if you multiplied it across, you'd still get x cubed. And now I have 3 separate special limits, and each of these, the limit is 1, as we showed up above. And 1 times 1 times 1 is just, again, 1. Okay, so I like this approach because I'm going to use that approach a little bit more as we move down, where you're just kind of giving fractions space to breathe so that you can kind of have separate fractions going on. But you can also use that idea where you're kind of factoring out that cube to the outside. Either way, you're going to get 1 for number 2, either way. Okay, now, number 3, the limit as x goes to 0 of secant x minus 1 over x secant x. Whew, we made a little bit of a big jump here, but I promise it gets easier. So the big thing here is that we went to a trig function that's not a sine or a cosine, all right? If I go back up here, the only special limits I have involve cosine or sine. So if I'm going to figure out a secant, I'm going to have to switch it to sines and cosines. So I'm going to use my identity, and the identity I'm going to use is that secant x is 1 over cosine. And I'm going to use that in both places. So I'm going to go ahead and sub that in. So I'm going to have the limit as x goes to 0. And instead of secant, I have 1 over cosine minus 1. And on the bottom, we have x times, and instead of secant, I write 1 over cosine. Okay. Now, you may be saying, oh my gosh, you made it so much worse, which I did. But really, it is on its way to being better, because what I'm going to do now is I'm going to go ahead and clear those fractions. So right now I have two denominators. They're both cosine. So in order to clear those denominators, I'm going to multiply the top and bottom of the big fraction by cosine x. And that will clear those out. Now don't forget that you do have to distribute to both pieces in the numerator. So that means that this is going to simplify to the limit as x goes to 0. Now, if I take the top, the cosine x times the 1 over cosine x, that cancels out and I get 1. And then 1 times cosine is cosine x. So on the top, I have 1 minus cosine x. On the bottom, this cosine cancels with 1 over cosine, and I'm left with just my x. And the reason why that is so great is because now this is a special limit. 1 minus cosine x over x for the limit as x goes to 0 is just 0, and then I'm done. Okay, so all I had to do was use that identity to switch the secant to 1 over cosine and then clear my little denominators, right? The cosine x that was in there. And that allowed me to go to something that ended up being special. Okay, so a little bit tricky, but whenever you see something that's not sines and cosines, switch to sines and cosines first and then see what kind of algebra you can do. And that's going to wrap it up for our lecture.